client server with a GUI app on the end. Out of my experience, I come to have certain gripes about the Smalltalk environment, and I have like one foot in the Smalltalk community, one foot in the Lisp community. So one of my desires was often to mix the languages together, and I think I found, along with a friend of mine who works at Carnegie Mellon, who's going to turn the compiler work into a research project. A successful balance of the ideas that you can actually move to from existing Smalltalk applications. Does anybody ever have any Smalltalk experience? Sometimes it's for something called traits, which are shared behavior objects. Because of multi-methods and because of the semantics, we can't dispatch on we dispatch on individual objects, but once we've dispatched on that object, cloning it as we do itself will not really carry forward that dispatch. You have to duplicate the method and do all sorts of strange tricks. So to keep things simple, like the state will change, the state will carry over into the clone, and we have to rely on a delegated object in order to carry forward the behavior. Expressions are all message strings. Dispatch is dynamic. Depends on all the arguments agreeing with each other. It's sort of a distinction from the generic function and instances of generic function being methods view of things, where you have a generic function that maintains the whole lookup table and decides from there. Block objects are closures. We use real closures. We use tail recursion optimization, bit of unrolling. And methods happen to be named closures. It's a little bit different from Smalltalk, where blocks and methods are slightly different for subtle reasons that usually have to do with just expediency in the implementation, plus the language hasn't changed from that. All right. It also has an experimental system. We're not quite sure how we're going to do it, but real macros. We have syntax trees and a way to manipulate them at compile time. Next slide. Small overview of self. For those who are not familiar, I mentioned a decent overview of it. Objects themselves are the center of focus. We're actually considering the Morphic user interface as well. And they're supposed to be very direct and physical. Multi-methods sort of add to this, but multi-methods have sort of an environment character, obviously, where you're no longer having your behavior being owned by particular classes of objects. If you want a new object, you do clone one that's already live. Cloning takes the template and uses the same attribute value pairs. And a lot of those slots will be delegate slots. So that's how behavior carries forward. I'm mentioning sort of a self-attribute and a little bit of a slave. Objects that have behavior itself by storing methods in slots. And you can actually assign and update methods by doing that. Values and methods are accessed by roughly similar syntax, although they have some special extensions. Objects share behavior by slots of perform delegation. You can have multiple delegation. You can have ordered, and all sorts of weird options came out in Self 2 and 3 that you could hear before, so it's hard to say for sure what I should really describe. Next slide, please. Why use Smalltalk? Smalltalk hasn't really changed in 20 years. That's longer than even Common Lisp. And Smalltalk has an ANSI standard, but nobody really pays attention to it because all the Smalltalks don't really deviate too much. However, in the last 2 or 3 years, with the advent of all the research going on in Java, there's a multi-method version of Java. There's a Java with mixins. There's all sorts of mixtures going around, and people are taking things like aspect-oriented programming, porting it to Smalltalk, and saying, yes, this is a win situation, or at least it's worth looking into. And they're starting to look to extension libraries, but they're not really changing the language itself. Self-instruct Smalltalk in the early 90s promised some change in the relative performance and the general outlook of how the Smalltalk systems were built. But Sun basically brought them up, and we got Java instead, which I don't think anybody here is really a big fan of Java. There's SmallScript nowadays, which has it's class-based mixins, and it does have a type of multi-method. Basically, it's an overloading for particular REST argument types, but they're really owned by the same class, so it's not quite the same thing as a class. SmallScript also, SmallScript also is .NET specific, or the agents, the AOS runtime system, which is actually pretty amazing, but it's Windows only and it's not free. So we're trying to make an open framework to support an alternative. And we believe we have the right combination of ideas at the right time. We've expanded the expressiveness of the language while we haven't introduced so many new odd concepts. We believe that it's too much of a transition shock for people who want to move their programs to something more powerful. So we decided that it was easy to give the Smalltalk community an upgrade than to basically make a new list that would be competing for the same type of mind share that Proto, Goo, Arc, and Common Lisp and Scheme obviously are all obviously provided. Next slide, please. How do we do multiple dispatch without generic functions? Multiple argument dispatch is obviously a big win. It's more expressive. You don't have to refactor your program just because you decide that a method is often in object-oriented programming. You have your refactoring technologies which will do special work to make sure that the method that accesses too much of another class gets actually moved to the other class. So you change the external accessors to direct access and all sorts of things. And with multi-methods, that's almost a non-issue. You can still inline both types. You can optimize for both types at the same time without any change in the actual code. We caught on with the idea of multi-methods, and where are they now, basically? Cecil did have classes, but it's a static language. It was sort of a contradiction about the prototype ideas that you have object-specific method additions, and they also had predicate dispatch, which they managed to optimize fairly well, but it's still a little bit of an overhead. But Cecil is not dynamic, and no one, aside from being a good bootstrap platform, a great research characteristic, it didn't really go anywhere. Dylan did. Dylan was dropped, unfortunately, by Apple. They're still brilliant, but it's hard to say if Dylan's really going anywhere lately. Maybe I have the wrong impression. Does anybody have any thoughts about Dylan? Yeah?
Harlan gave it away to one of the founders, Doc, and it's a website Somerville. That's a lot different.
Okay.
And that website hasn't changed in 2 years.
What's that?
That website, the functional objects hasn't changed in 2 years.
Yeah, that's right. I seem to remember that. Either of these is centered around objects themselves, or has the collection of simple concepts and no fluff like Smalltalk does. I'm not going to give by the way, I'm not going to give like a full introduction to the language. There's a manual. I have mini CDs that if you want to check out, or a website has a manual that you can digest fairly quickly, and we'll go over all the concepts, and it's fairly formal. Next slide, please. And how do we get prototypes and multiple dispatch work together? This is a continuation of the previous diagram to explain how we do it without functions. Objects are groups of slots. Some of them delegate to other objects. Objects store their message, their method, in a role hash table instead of state slots. This is sort of hidden in the basic view of an object. It's sort of a meta aspect. If you wanted to make a mirror, you would probably find those. But they're not part of the state of the object, and they don't constitute a type of ownership. It's just a simple means to implement lookup. Roles describe what positions the object can play in a method. Often you'll have in the numerics, you'll have several implementations of addition that deal with the various types of the arguments. And it'll show up, there'll be one implementation where it will show up in the first argument, another where it will show in the second, and another where it will show up in both. This is sort of an exercise that we did, but it may not turn out to be, a little bit too much for just dealing with, basic and such. The compiler may be able to optimize that away a little effort. Lookup proceeds, and this is a one-liner. They kind of describe something incredibly complex, but relatively fast. Lookup proceeds by consulting the arguments themselves at runtime, finding out what methods they support by traversing the delegation trees, helps out. And then applying the first applicable method. And we also have resends, directed resends, and we can resend with wholly different signatures instead of just simple resends. Instead of just a call next method, which is available as a simple method resend. Do you have any questions about that? That's a broad overview. Yeah.
Yeah, there's been a lot of research done even 10 years ago in the ordering of applicable methods. And CLOS has taken one approach that was kind of revolutionary at its time, but there's been some refinements to show how you get the multi-graph, how you get some more rationality to it. That seems to be the biggest problem. So I'm kind of curious as when you talk about the first applicable method.
Okay, I can describe the method ordering. Basically, the last delegate added is generally generally takes precedence. It belongs to the new type of number. It's breadth first search, basically.
Is there any time being imposed by the classes of objects or types of objects?
Well, you have multiple delegations, so it's not quite a hierarchy. But let's see. That we haven't worked out all the issues with method ordering. We basically chose a simple class-based method where each argument is more important than the following argument. So the first argument is search first, and then unless some following method some method found in a following argument contradicts the original method in its type sequence, we just use that one. And it seems to work pretty well. We haven't had any issues yet. It seems to be fairly intuitive. Let's see what else. That's a nice broad picture. We have a whole 7-page paper just on the algorithm that we wrote before we actually wrote down the language, and it's on our website and on the CD-ROM. No, it's missing on the CD-ROM, but it's on the website. Next slide, please. We picked this model because we wanted people to move from single dispatch to multi-dispatch in a fairly fluid way and not really give a lot of overhead just because they moved to a different lookup model. So if you have single inheritance and you have simple methods that only dispatch one time, there are special optimizations that we have to make sure that there's less overhead. And let's see, yeah, that's the basic idea of it. Okay, next slide. And this is a high-level overview of the syntax. Just sort of skip through this really quickly because there's some other things I want to discuss. But you have unary messages, which are simple alphanumeric names. They can have symbols in them. Because we implemented it in common lists so that we could eventually have that general notion of a symbol. For example, you can add slots to symbols or add slots to numbers of dispatch on individual literal objects in much the same way. Basically, your unary messages are sort of a postfix notation. The result is passed to the next the surrounding expression, which will happen to be on the right. Let's see. Binary messages tend to be things that we'd rather have symbolic, and we want to have look nice when the manager is looking over the programmer's shoulder. Smalltalk tends to be a good language, especially for the keyword syntax, for people being able to read a business logic proposal and look at the code and say with reasonable certainty that looks about the same. Unary messages are applied first, and then binary messages. And next slide. Binary messages have no individual preference. It simply goes left to right. Self actually required you to disambiguate what the expression was, but we decided that traditional Smalltalk has more developers, and that if we move forward from them, we could probably eventually evolve the language from within, given that we already have people with a fresh start. Keyword messages are a lot like keywords in lists. except they are sort of mixed. They alternate between the first argument and the next argument and keywords in between. They're parsed all together. We have a system that just looks ahead until there's a whole parse time involved, so it's a real parser and a real lexer, and we wish we had a read system that it was that extensible, but so far it's just a pseudo read system. We have a type of read table that's somewhat factored out, but there's too much looking at involved to really use that generally. We may get to it eventually. All right, next slide. We have optional keyword arguments. We use the and symbol from list, and they're passed through the argument and keyword name are passed through and a special dictionary type of register. We may change the implementation at some time because it does sort of add a decent amount of overhead just to collect all those arguments and pass them in. If you don't know Excel runtime, we have no generic functions that'll declare what keywords are available or anything like that. We may add a metadata object protocol, and may add where we're thinking about is slot definition objects and generic functions are considered more like protocols. Sometimes even two different trees of methods will have different types of semantics, and that doesn't adequately express by a generic function. So we may have to do that kind of model. Keyword methods. For those not familiar, Smalltalk uses, or the Smalltalk family uses closures to implement its control structures in an extensible way for nested passing, optional evaluation of blocks and such. Side effects do affect the closures. It's not simply a matter of the top level environment being able to be affected. It's all sorts of things being able to be accessed. It's a little more hackish. But it does work for most situations in a very safe way. The header here is limited by vertical bars. The input variables are preceded by a colon, and the local variables have no preceding mark to them. If you'll notice, anybody who's familiar with Smalltalk will know that they use explicit assignment. We have no explicit assignment. What we do is we provide all slots with, right now we provide all slots with accesses and mutators explicitly. That's one of the reasons why we want slot definition objects, so we can modify that to have only a reader, only a writer sometimes, or write one, so we can have all sorts of different options. So for now, you see what I did was write down calculated discriminant, something very basic and algebraic. The discriminant keyword there is taking an implicit first argument, and this sort of reveals what's going on in Slate that's slightly different from everything else and makes it a little more tricky to learn. That's the one thing that might bite newbies, is that there are all sorts of, basically any identifier in any place in any expression is an accessor into the surrounding context. In this case, DISC, the discriminant, is an accessor into the local slot of that block of the closure. Once you assign it, because of the precedence rules, let's say that I wanted to assign a keyword or the result of a keyword expression, the precedence rules would force me to put parentheses around the keyword expression. Self used a convention where all keyword messages had to be defined with lowercase keywords, but if you wanted to group together keywords and not have to use the parentheses to disambiguate what keywords belong to what selector, you capitalize the first selector of the next message. That turned out to be, I don't know too many. I was actually talking to David Ungar the other day. I had a meeting about it, and we were talking over Slate's different ideas that have come about in relation to it. And he actually said that he kind of regretted that. It sort of it restricts what you can do with the keyword syntax a little bit, and it's a little harder. It's actually a lot harder for a code analyzer to figure out what the parsing is for that. Let's see. What other conventions do we use differently? This is invisible in this particular method, but the return is an actual binary selector. We may change that back, but it's been fairly nice to us so far, and you still need, if you have a keyword keyword expression or a binary expression which you want, or a binary selector expression which you want to return. Then you need to disambiguate the parentheses. Sorry, next slide. Closures are objects. You can clone them. You can invoke them multiple times. Slots, sets, and gets. Yeah, this is for those for the last slide, basically. Early return is a binary method. So you can also access the context explicitly. Because of the lexical scoping and because of all the different objects that are involved in the series, and even in the main environment organization, we use namespaces such as in self and the main lobby, which is where most objects come into existence, inherits from other packages, from other namespaces, which contain further sets of traits and prototypes. So what we do is we provide at various important places, we provide direct access, loopback slot, where the lobby contains a slot to itself, the context contains a slot to itself. Self had this idea, Smalltalk somewhat had this, Smalltalk definitely had this idea, although it doesn't really have a good namespace and because it's not general. And so that allows you to target your updates a little bit more successfully. Next slide. That's enough of that. Slate reserves the add character. This is another big change from Smalltalk. We needed a character that would adequately express joining together, and Smalltalk uses this as a binary selector for creating points very quickly. It's sort of like their own version of con cells, but they only use them for screen points, two-dimensional points. What's happening here is that you have an argument name which you do to express your method declaration in an abstract view of how it would actually be called. You give it names of the method. If it's an underscore, it's totally ignored. It's just collected somewhere and doesn't even get into the closure. The add dispatches on a particular object, which now the message sent there has to get disambiguated anyway because it looks like binary. At the end there, we have in the header merges that. There are any errors that will go into compilation. There's a difference. You declare an input slot as a low in the shadow. Empty block there again, just empty block terminal, sequences of statements, which are kind of crossed over in periods and then you execute sequentially, and the side effects have to happen exactly that order. Okay, next slide, please. Underscores the key way to discard input. Trace is shifted elevation, and the code objects contain all the methods. Full expression. The definition itself is an expression that returns a closure or method body that is resulting from the rewrite. And what happens with that closure that actually has to be pointed back to the object it delegates to, and the runtime is eventually going to be doing things like file packet, updating all those slots, going through the loop and handling the trade fairly transparent with all of those. These are all basically annotations. of the advantages, or our perceived advantages. Prototypes give you a direct way to build environments, just like so. Trades are still there and necessary whenever you want shared behavior, so it's still comfortable for a class leader. You can simply substitute this for class and actually have their own trades, which can be customized as well. There are trades utility methods called derive and derive with. They'll build a new prototype and return it, which you can place in your namespace, and it will clone and set up a delegation chain for a new trace object. There's also derive with, which takes an extra array of mix-ins and will create delegations in that order. We'll mix those in the order that they're presented in the array. Multiple dispatch allows you to express behaviors in relation to writing between objects instead of privately held responsibility for a feature. It does make things interesting though, because traditionally in Smalltalk, you have a whole image-based application sometimes, and modularity, even though it classes own methods and such, modularity is not expressed by that same mechanism. So this allows you to sort of see it a little better. You might see that particular set of multi-methods depend on two other packages. One set from the main type, or the first argument type, one set from the second argument type. Dispatch on individual objects allows you to special case your system. Object by object, it means false and nil are handled. And particularly good for global and single things. We have to do some interesting things with standard in, standard out, so that they have nice shell, reminiscent syntax. It's just sort of a feature we do in there, and we'll see how people like it, or if it turns out to be a little bit worse than anticipated. Another thing we can do is we can basically write functions in namespaces, and it's basically just a method that takes the implicit first argument and just dispatches only on one particular namespace. So if you write facility methods to say clean up the namespace or provide some analysis like that. Next slide, please. What lessons learned? We created a slate symbols. You can dispatch on them. You can store slots and access them. We do not have simple packages, but it's something that can come along down in the future. Closure headers can declare the types of their slots by having the exclamation mark's a little unclear, but it's an exclamation mark, a bang, followed by a type expression for the possibilities of optimization and customizing. We already have type library, manifest types that are all object provided, they're not primitive. And we already have a type inference system which we can carry over and try to enhance from existing small types. We have also derived types and parameterized types. What layer? I'll mention that later. Utilities, macros, things. I have the reversed order. Basically, methods can be applied at compile time by prefixing the name and with the backtick, basically backwards character. This will take a method that is defined on the compilation nodes, the nodes that you define and generate with the parser, and it will take that expression before it's actually evaluated and apply the method to the tree. Most universal example is backward evaluate, which substitutes the value of an expression at compile time into the surrounding code. We all know sharp types, so there you go. Next slide, please. The backtick is not part of the method name. It instructs the compiler to apply the method to the objects that represent the parse nodes of the expression. Slate parser includes features added to the parsing result tree objects for quoting, unquoting, code traversal, argument traversal, and a lot of other facilities that we're just beginning to look into. The primary disadvantage of this, the primary disadvantage of this is that you have to overload the parser objects. So you tend to get a cluttered up namespace so far. We may try to provide a special module system where you can load and unload methods depending on what context you're in. Some basic macro methods are quote, unquote. We don't have a quasi quote actually. Unquote seems to work well. We tried to provide an distinction between quote and quasi quote and found that there wasn't a real reason to. There's also a label quote. What label quote does is it takes a little expression and something that's constant, and you can quote and unquote to that level. And I wrote 0 and 1, but it's supposed to be 0 and 0. We tend to use integers in our practice expressions, and the nice thing is that because this is more verbose, it obviously takes a lot longer to develop the right. If you have a macro generating macro, it would take a lot longer to figure out the right level of nesting. And so what this does is it kind of bypasses. It gives a little bit of shortcut. Code traversal, we have a test method, and I forget if it's on the CD because we've been not checking it in the CDS sometimes, so it may have some very old version or something like that. We take an expression and we can essentially try to do the same thing as we'll take a term and use the value of the term, not some type of term or anything like that, and we'll substitute it with another term. And it's simply done by code blocking and trying out an example. And it does tend to filter things out based on the type of the parse representation, but that's just an advantage of the syntax. Next slide, please. So the slate is intended to be a clean slate implementation of Smalltalk using new ideas. This is one of the main reasons why we went ahead with this, is it was an advanced enough step from existing Smalltalk that we could start over and we could integrate all sorts of things that we've seen in other environments that we never could get going in Smalltalk, particularly Squeak. I've been using Squeak for about 4 years. It's a nice integrated environment, but it's got a lot of craft. So we use multiple delegation to allow what we have is a refactored collection. The classic collection hierarchy is no longer. It's sort of a bit like Strongtalk, which is based on a paper in 1992, which described how to make relatively type-safe factorings of collection classes using mixins, and also it factors out some protocols as well, which helps out, at least for extension. We have various open points of extension, sort of abstract classes or abstract traits, I guess. Where you can take like an array and you can treat it like a set. There are some limits to it, but it allows you to. We have, like, for example, red black tree and other implementations that you can freely use as a setter or a dictionary using some methods that we've provided. My friend Lee, who works at Carnegie Mellon, is going to work on a bootstrap optimizing compiler. Some of it's already done. He did some of the prototype work in Squeak, and he was doing work even before then in Rescue, trying to help out Steelbank, and then realized that he kind of wanted to do something different. I don't know why, that's his choice. Based on the dynamics of Self and the Hotspot project, but we're probably going to go even farther than that, or try something lighter, that's for sure. We want to perform, this is my personal project, and unification and the cleanup of the ideas behind List, the Common List Interface Manager, and Squeak's morphing. So we're going to take direct manipulation, the ability to create objects from nothing, and put them together in an interface, specify layouts, and all that stuff as you see it, even add state to the interface itself using visual inspectors, and integrate it with the presentation type system. Well, not integrated directly, but have them both be able to affect the same tree of visual objects without conflict. If some management needs to be done whenever you clone objects, we have to do some almost done. But there's a lot of promise in it, and there's a lot of insights I've come up with that I think will make it work. So yeah, it's supposed to allow multimodal development, direct manipulation, construction, and presentation-based interface abstraction. And the means to move between those. That's something that I'm even more interested in is to be able to push your code to something more modular. And much more. There's so many ideas that we've had that we may get around to, or we may not, depending on how much work we can actually put into this. Next slide, please. So in conclusion, Slate is an important step forward, at least in my opinion, for the Smalltalk family language. It is an open project with lots of potential to draw from over Smalltalk and over the communities. I keep my feet in both camps, and I like both. For more information, including the full manual, I've got many CDs with videos of the self user interface system, plus some self-derivative languages along with Slate. Basically the archive of the entire site plus the code object. And slate.teams.org is the website. Any questions? You like it? Do you not like it? You know what's up?
Can you give us a sense of the kinds of things that you feel are easier to express or somehow more satisfying to express in Slate versus small talk?
Actually, there's a dimension unit system that I imported from Smalltalk, which was using a lot of double dispatch. It's probably my favorite example because there were something like 51 methods, 51 implementations of 8 methods or something like that. And I got this just to put it down somewhere just because I wanted to have it available. I reduced it down to 17 methods with only 3 selectors. And that kind of thing helps out. There's also the visitor pattern. The visitor pattern just, if you ever use Class, you know that kind of thing is just an artifact of single dispatch. And I know in my class systems, I tend to get more instance-based than the average guy, so maybe that's something I appreciate at least. And I know Clem actually uses quite a bit of instance-specific stuff, but it does support for our class. Anything else? Yes?
You mentioned weak pointers, the methods, carry weak pointers back to the objects.
Yeah, the code closures carry weak pointers. The actual structure of that is provisional right now. It's going to change.
It's easy to see how it might be better if you have a class version of grouping of the objects. This effectively how you implement the weak pointers is we go without that.
Yeah, I know. That's what we're trying to move forward, and we have lots of issues to deal with. That kind of thing is probably going to come up. I don't know. I don't have an answer right now. Yeah.
We were contacted background and just because it seems like the energy of Dylan has sort of maybe gone over there and sustained the second generation season as twin.
Right.
It would seem like there's a lot of, even though you guys are kind of on different syntactic planes, it's also a waste to have you each off trying to do whole languages and like you should be consolidated somehow. I know small talk is kind of different.
We've definitely considered a sex-based access mode for the system. The keyword messages tend to hit, if they're not implemented, they kind of look a little wrong. Other than that, it seems fine. Because we use Lambdas for closures and some other different things. We're not in direct contact with them, and we really shouldn't talk to them because they abandoned Proto, and we were kind of disappointed about that. It's one of the reasons why we got into this in the first place. One thing we're particularly interested in is providing an open, fast, clean, small talk implementation that does the just-in-time hotspot type inference and hopefully runs pretty tight. Obviously, we won't go into those, but it should be interesting. It's something for people to really learn from and draw and get further compilers, which what I gather from the implementers that I talked to at various conferences, they're rather good. I think even worse than most. Last question. Anyway, if there's nothing else, thanks very much.